Okay, so I've cut 20 lengths of wire equal. I've just wrapped them around here mechanically, and I'm going to apply the solder to them. I use a Franco Manca box because my kid likes to eat the pizza, and it's very handy for holding it. This should also allow it to dry or set without moving the wire, so it should be better. Then I'll put the heat shrink over the top. So let's just get on with that with the soldering iron. Okay, so now I've made up, ready to solder, 4 with a grey, 1 with a blue, and 4 with an orange. At least I think I've done that. The blue and the orange will be the control wires for the quadrature. So they will go into an Arduino or some sort of microprocessor, and then they will push their signal back out to the to the pedal. And the blue one is going to be used for the tuner. So again, that's going to go into the microprocessor. When it senses a short across there, it's going to send the pulse to the left and right buttons. Yeah, the rest will be red. So that's what I'm doing here. So now I've got a tester switch. So I've just got it wired up into a harness onto the continuity meter, and that one passes. So I'll go on to the next one. Yeah, he's working. So I'll just do that, and then I'll put the heat shrink on when they're ready. It's slightly easier if I just put the towels like that, so then I don't have to keep finding the wires. Yeah, so that makes my life a bit easier. Okay, because I've got it, I've decided to go with 6 different colored wires. Now bear with me. I think, I don't know if that's green or blue, who cares, it's one color. Then there's a yellow, then there's a brown, a white, an orange, and a pink. And then I've got 5 reds, and the 5 reds will be for like F1 to F5, and these will be for one of the others. I don't really care. The point is that there's 11 switches left, 5 times 2 plus 1. So I need 11 colors. So I've got 5 reds and 6 different colors. I know that the blue, which isn't the same as that, is, I'm going to use that for the tuner, and I'm going to use the grays for one side of the control, the quadrature control, and the orange for the other side. So I'm going to get on with that now. Okay, that will heat shrunk nicely with the hairdryer. So now it's a case of wrapping the wires around and putting some DuPonts on, or leaving them ready to solder. I'm not sure what yet. I guess I'll wrap them for a bit of tension, put a bit more DuPont on the outside just to give them a bit of strength. So they shouldn't be tucked, they should be inside a box, but let's just do that. Okay, we're going to wire in part of the switch here. We've got some headers going into 10k resistors going to another side. And what I've done, I've got 2 types of headers. I've got some that are better quality, and you see they're much longer leads, and the other are shorter. So I'm going to hold it in and just solder the dual. I'm putting them through the same hole, yeah. Then I'll cut the traces along there because I don't want them to go across, otherwise it'd be pointless. Then I'll make some space for some transistors. Let's get the first set done first. Yeah, this is basically tacking that. Okay, the first bit of soldering, I'm not a brilliant solderer, but I think that will do. I have to check it. I mean, obviously I could do better, but it's quite close work. I use quite a thin solder. Now, the idea is that input goes to switch through a resistor that's at a chop, so it's not in the circuit. This comes in from the switches, which are down here. So this comes in from the switches, so black goes to one end and the other color goes into there. Oh, can't see what I'm doing, like so, say. I'll put a proper DuPont connector on, but basically into there, like so. So that's the switch then that can influence. And then we got to put this transistor in. So normally it would be, there's the flat, that way round. And that's the base, isn't it? The collector's in the middle and the emitter's at the top. But you can't really wire it in that way. So if you turn it like that, you see you haven't changed the pin. So if this one is the one I want to be the output, it's still the output like that. And if I go underneath here with a couple of breaks in the board, so let's see if I can get this right. Let me pause it. Yeah, if we go under the board like that, you see it's still basically the same way round, and this middle pin acts as another input. Now that's going to the microprocessor, yeah? So this one here would act as the microprocessor, and I'll use a female connector there. This one needs to go to earth. Strictly that should go through a resistor, and there is space on the board to stick one in, and it would be logically connected across that second row there. So I could stick a resistor in the top hat form. I mean, you just need to leave this a little bit like that to give a bit of space to get the solder in. But then, like I said, the output by my thumb is going into either the switch or straight through, well, switch and straight through, yeah, through the resistor into the output on the right here, which will go into the switch. And if it's 3 volts, there's no change. And if it ever gets shorted, then it's been effectively switched. This row here, although you can't do it like that, needs to go to earth, but there's nothing stopping us basically running some solder or something along there and taking that to earth. Or again, we can use that trick where we could take the DuPont connector onto there, go into a common earth, or yeah, that's the way I do it. Or I could wire it into a different board. So that's the plan. Oh, I don't know if it's going to work, but you see what I did was I offsetted the transistors. So I just bent the legs and put them on the underside, which was quite hard. I needed a gap, but it turns out that this height here just happened to be enough to stand up the middle pin, and the middle pin going down that row there, column which we're going to look at, it is going to be used to put female DuPonts on. Then, like I said, that should go to the 3.5 volt on coming from the DB25 connector. That should come in from the switch. This goes to Arduino in the middle. That goes to ground. So I'll just basically lay a wire along there and solder that all together. And the front one we don't need. We can chip that off. We can chip those things off there. Oh, we've got more. Oh yeah, that's the resistors. No, that's the transistor legs there. Yeah. So resistor legs come off. 2 of the 3 transistor legs, apart from the middle, come off. They all get put together as a common earth, and we'll have to see if I've got any solder bridges across there. I don't think I have, but you never know. Okay, so the other side of the base of the transistor, we put 1K. This is a slightly inferior 1K, but it's still 1K resistors. I'm going to wrap those round with a bit of heat shrink on it, put them in a line here, and then I'll have another riser coming out. This is where the input from the 25 pin will go. This is where the input from the momentary switches will go, and this is where a microprocessor can take its input or output, in fact, and it will basically jump over the resistor into the base. A very gas job of soldering all of the rear lines together, and I need to cut this track where my thumb is. So that will give us a they're all going to be tied to earth, so all the base the what is it, the EBCB emitter, is it? And yeah, so that's all earth there, so that should work. Yeah, let's give that a go. What we got here is an ESP32 that's simply supplying 0 volts. And that's going in, into the chain, the common ground that I built for the transistor array. Then we have this wire here going, where are you going? All right, into this yellow one here, and I lose it in the keyboard, and that is going into pin 1 of the breakout of the zoom extender. So we got the power line going in there, through there, into the front here, and then the outside I think is pink. I'm a bit colorblind. That's going into my little switch, and the black is going into one of these banana plugs, which is also tapping off that ground. So when we pick this up, see if I can hold it, I'll get both in view. Hang on. Is that in view? Difficult to see. Yeah, it never quite gets into view, does it? But that's going down, basically. Let me just see if I can check that. I don't know if I can change the contrast, but that's basically going down, yeah? 53, 52, 51. So that bit's working. Now what I'm doing is installing Arduino and see if I can get that to work. A bit clearer now. We've got, well, maybe. We've got 2 wires coming in via these banana plugs, here and here. And these are, oh, the brown's dropped out, so hang on a second. There we are. So let me see if I can use this as a pointer.
we've got the two wires here coming in. I don't know if that's pink and brown, whatever, and those are going into the control wire here. So first, skip, second, yeah, that's how to remember it. So now, see if I can see that display. Yeah, I can. Now I can see it like that. So I'm going to push. This should go left, I think 44. Yep, and 43. This next one I push should go up. 44, 45. I don't know if I can do this. If I can put them both together, which is really hard with one hand. I've got them. No, I haven't got them. This is why I need to put them into a frame. Right, let's see if I can push them both together, and then the tune should come on. Hang on. I didn't quite get it. No. Has something come out? Ah, the wires come out, that's why. Let me plug it back in. Now there will be proper DuPont ends on them at one point, so it won't be quite so flaky. Grab those two together. Push them both at once. It's come out again, damn it. Let's get this little mofo in there. You know, I could put the DuPonts on, that might make life a lot easier. Okay. Grab those two together, make certain it doesn't jump out. I'm watching that. I've got them. I've got them. Let me push them both together. There we are. Push them both together again, push them both together, push them both together again. So that's it. That's working nicely. I'll be working on the Arduino side. The problem is my Windows box has decided to update to Windows 11 some service pack. So I can't load my Arduino at the minute. So I'll do that in a later video. But the main thing is that this little board here, I'm going to carry on checking these. At least the inputs are working here. I'll finish checking those and update you. Thanks. Bye-bye. Okay, I'm still waiting for that stupid update. But you see I'm using the 3.3 volts coming out of there. And that's going into... No, it's not going into there. That would be dangerous and stupid. Hang on a second. 3.3 volts is there. Oh, it's this black one, that's why. And the 3.3 volts is going into the other side of one of the switches now. This one here. And then so that means it's going to give 3.3 when we close the switch. And at the moment it's open, so nothing's going through. And that one's going into the white one here, which is going into the first input to the transistor. So now if we look there, when I click this button, it will go down. Yeah, it'll trigger it up, yeah, because it's on that left hand one, yeah. Left hand, right hand one. Ah, yeah, it might be on that first circuit, but then that first circuit is coming through here, into here, and into... Yes, you see it's going into the orange, and that is channel 2. Yeah, pin 2. So that is right, in fact. So it's kind of counterintuitive. The way I wired it in right now, it's working. So what I've got to do is to move that wire along here, and it should always be a right, and that will allow me to check that the transistor inputs are working. So I'm going to get on with that. Okay, so what we've got going on here, this is as if it's coming from the transistor. So that's going into this little junction here, and one end is coming out here into the pedal, and the other end is going into, I think, channel 1. I don't know, I'm a bit colorblind, yeah. Then this one here is going into this little junction here, and one of the sides should be coming out to this pedal to here. Yeah, sorry, this one here is going into there, into the measuring, the logic analyzer, and also into this pulse generator here, which is going to simulate the foot pedal. And then finally the output is going into this measurement device here, and one is going there to the actual device, and the other one's going to the logic analyzer. So now watch the logic analyzer, and what we should be able to see is periodically the top one will pulse down. There you are, every 5 seconds. So when it does that, Let's see if we can get in closer. This one should pulse. I'm watching the screen. Pulsed, yep, it should have pulsed 59. I'm watching the screen, and it's going to pulse now. There are 10, right? Then this one here, we can go click, get in, click, 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 and now we can watch it on the screen. So the bottom trace here, I hold it down, you see it goes down, and then the other one will pulse every so often, every 5 seconds. So in effect, this is going crazy, yeah? Or I can let go, and then every so often, this top pulse will come in. There it goes, and I can pulse it myself, see? And you see it gets measured on the output, because by definition it goes to the output. So, how did we do this? Let me just stop this a second. Basically, we're using an ESP32 in this case, because it's 3.3 volts. We're using 2 pins, or one in particular, pin 4, and we're setting them as output. And what I made the mistake of is I want it low, because the circuit I'm making is inverting it. So I want it low, and that will keep it high. It sounds stupid, but it's true, yeah? And then when I set it high for 50 milliseconds, that's enough for a single pulse to go in and pulse the unit. So basically, what would happen is if this ESP32 receives, I don't know, a Bluetooth signal in, or whatever I want to control it with, MIDI coming in from somewhere, I'll be able to pulse the pin, and that has the effect as if I'm pushing whatever it's connected to. Okay, so you see I can use it as is. I can use it with this thing if I can find it. Ooh. There. And if I let it go, every so often this thing is sending a pulse anyway, yeah? So basically it seems to work. I thought I got it wrong, but it seems to work on those ones. I will wire the rest in to test them. Just going to run out of cables, I think, or at least inputs. But anyway, that's basically working now. That's pretty cool.